Right, this is lesson 4 in the trigonometry unit. Today we're going to be doing word problems. Before we do some word problems, I want to go over 2 different vocabulary terms that come up a lot in real world problems involving angles and right triangles. And they all have to do with perspective and which way you're looking. So when you're talking about an angle, we often say something called the angle of elevation. So if you can imagine yourself looking straight ahead, it would be the angle of elevation. So the word elevation means upwards, also called inclination. It's the angle your eyes move to look up at an object. So let's say you're looking up at the helicopter. This is the angle of elevation here, that your head moves upwards to see that helicopter. So I'm going to just highlight the angle so that it's not confusing. So imagine you're looking straight ahead, and it's the angle you move upwards. This is always the angle that's next to the horizontal line. Angle of depression is the other direction, or angle of descent, sometimes it's called, is if you can imagine yourself looking straight ahead and then you turn your gaze down to look at something. So maybe looking at a ship if you're standing on a cliff. The angle your head moves downwards to look down at something is called the angle of depression. So we have the angle of elevation and the angle of depression. The one way in which those 2 angles are the same is they're always next to the horizontal line. It's just one's moving upwards, one's moving downwards. So let's practice using some of these angles. Example 1, it says an airplane at an altitude. That means, that's a fancy way of saying height off the ground. Altitude of 850 meters is observed by an air traffic controller at an angle of elevation, there's one of those words, of 52 degrees. So I'm just going to highlight some of these things. What is the distance from the airplane to the tower? Okay, so let's draw this. So we have a control tower, maybe here, and we're looking upwards at a plane. I'm not a very good drawer, so I'm just going to write the word plane. I'm going to write here air traffic tower. Okay, so we're looking upwards at a plane, and the plane is 850 meters above the ground. Okay, the angle that we look up at is the angle of elevation. That's 52 degrees. So the angle of elevation is always, if you can imagine yourself standing there, it's the angle your head would move up to see the plane. And it's always the angle that's next to the horizontal line. So I'm just highlighting that horizontal line in green here so you can see it. So it says, what is the distance from the plane to the tower? So we're trying to find this distance here. I'm going to label it X. Okay, so let's do our steps. We're using the same steps we've done in all of our other lessons. We're going to label, write our ratio, and then calculate. So we're going to label, write our ratio, and then we're going to calculate. Okay, so let's label. So we have the angle 52. We're going to base everything off that. This side here is the opposite side. Typically I've used blue for that, so I'm going to highlight it in blue. Then we have the hypotenuse, and that's the side I want to find. Now the side that's not really important in this question is the adjacent side, because I don't want to find it and I don't have that length. So I'm not even going to label it. So I'm going to write my SOHCAHTOA here. And I don't want to use cosine or tan because those both involve the adjacent side, which I don't have and I'm not trying to find. I want to use the sine ratio because I have the opposite side, 850, and I'm trying to find the hypotenuse. So that's a good ratio to use in this question. So I'm going to write my ratio. Sine of 52 degrees is opposite, 850, over hypotenuse, x. Okay, so now, so I'm just going to highlight there to make that clear. This is the case where we want to do the cross multiply. So when the x is in the denominator like this, the thing we want to find, we just swap it with the sine 52. And so we bring the x up top on the other side. And that's what I type into my calculator. So now I'm on the calculation step. where I type in, I'm just going to clear off what I had, 850 divided by sine of 52. Okay, looks like I've got about 1,079 if I round to the nearest meter. So the answer is 1,079 meters. Question says express it to the nearest meter. So that distance there from the plane to the air traffic tower is 1,079 meters approximately. Okay, let's do two more where we have to draw some pictures. We have a lighthouse on a cliff that is 51 meters above sea level. A lighthouse keeper is 10 meters above ground in the lighthouse. Okay. Observes a boat at an angle of depression of 50 degrees. Okay, so he's looking down at the boat. That's important. How far is the boat from the base of the cliff? Okay, so let's draw this out. So I have this person. He's standing in a lighthouse on the top of a cliff. Okay, he is 61 meters above sea level because he's on top of the lighthouse, right? He's 10 meters above the 51. And he's looking down at a boat. I'm just going to draw a really bad boat. There we go. And here's the hard part with angles of depression. The angle of depression, remember, it's compared to if you were looking straight ahead. So if he was looking straight ahead, and it's the angle his head moves down. So this is the angle of depression, 50 degrees. Okay, I'm just going to finish the rest of this drawing. Now what we want to find is how far is the boat from the base of the cliff. So we want to know this distance here. Okay, and we know this height is 61. Now the problem is that my angle is not inside my triangle, but I can use a little trick here. This angle here is just 90 degrees minus 50 degrees. Because it's a right angle, it's a square, but I have the one side of it. So it's 40 degrees is the angle that I want to use here in this question. Okay, so let's label everything and figure out what I want. So based on that 40-degree angle, the opposite side is here. That's what I want to find. And my adjacent side is here. The hypotenuse we're not given and we don't need to find it. So I'm not going to worry about it in this question. Now I'm going to write SOHCAHTOA. And I'm going to cross off the ones that I don't want. So I don't want to use anything involving cosine. So I want to use tangent for this question. So let's set up my ratio. Tan of my angle, 40 degrees, is opposite over adjacent. And then in this case, I want to just multiply both sides by 61 to solve for x. And that's what I'm going to type in, 61 times tan of 40. So I get 51.2. So x is approximately 51.2, where it says nearest meter, so 51 meters. So the boat is about 51 meters from the base of the cliff. The one trick here is that the angle of depression gives you an angle outside of the triangle. So you need to use this little trick to figure out the angle inside. Okay, now this question involves directions, north, south, east, west. So first thing we're going to do is just read it and then we'll remind ourselves what our compass is. So a ship is sailing from an island due north. When the ship is 15 kilometers offshore, it turns and travels east for 10 kilometers. What is the angle between the ship's eastward path and the line of sight back to the island now? Okay, so when we draw things with north, south, east, west, we need to use the right directions. North, south, east, west. So the ship is sailing north at the beginning. Let's start with that. So here's our ship. And then when it's 15 kilometers offshore, so I'm going to label that 15 kilometers, it turns and travels east, so towards the E direction, for 10 kilometers. And it says, what is the angle between the ship's path, east, so this is where I always like to highlight, and the line of sight back to the island. So this was the island. If I look, what it means by line of sight is if I look back at the island now from where I am. So it's talking about this. So it's the angle between the orange line and the green line. So we want to find this angle. I'm going to label it angle A. Okay, so let's label our triangle and set up our ratio. So this is the opposite side. This is the adjacent. This is the hypotenuse. The two sides that I know the side lengths for are the adjacent and the opposite. So let's write our SOHCAHTOA down. I don't want to use the hypotenuse, anything with a hypotenuse in it, because I don't have that side length. I want to use the tan ratio here because I have the opposite, it's 15, and I have the adjacent. So let's go ahead and write our ratio, and then we can calculate. So it's 15 over 10, opposite over adjacent. And then remember, when we're finding an angle, we use that inverse button. So that's what I'll type into my calculator. The inverse tangent of 15 over 10. 56. Okay.